Writing equations from real-world situations. I like to read the problem first and then read it a second time and highlight any key information. You want to buy a Tesla Model S. They offer a payment plan that requires you to pay $6,000 when you purchase the car. So $6,000 when you purchase the car. Then you have to pay a monthly fee. So each month you're paying this fee of $1,050. And that's each month. So each is like the word per, and it means divide and tells us that we have a rate here. And you do this to work towards paying off the rest of the car. Hopefully this scenario is familiar to you. We did some problems like this in the first quarter when we talked about linear functions from tables then. So let's take this information and start adding it. So they offer a payment plan that requires you to pay $6,000 when you purchase the car. That's no time has passed when you're purchasing the car. That's basically after 0 months, you're paying this $6,000. So we're going to put that in the table as the initial value. And then you are going to pay a fee of $1,050 each month. So we are going to add to that 1,050 to get to that next value. So 6,000 plus 1,050 is that 7,050, and we're going to continue this in our table and then sketch the graph. You are welcome to use a calculator. If you put that 6,000 in and add 1,050 and hit enter, you can see that we got 7,050. On a calculator, if you just hit plus after that, it's going to take the previous answer, which in our case was 7,050, and now we can add that 1,050 again and hit enter. So we get 8,100 or 8,100. And now if we just hit enter, it's going to keep taking our previous answer and adding 1,050 to it. So that makes it a little bit more efficient to fill in our table of values. So we can see here that after 5 months, we've paid $11,250 towards the total cost of our new car. So if we're wanting to graph this, we need to think about what's going to go along our x-axis and what's going to go along our y-axis. Our month, which is time, is what usually goes along our horizontal or x-axis. So this is our number of months. And how much we've paid, or the amount we've paid, is going to be our y-axis. So I'm going to label my x and y-axis to kind of give a quick sketch here. I don't want to spend too much time thinking about this. I do like to see if I have enough room. So 2, 4, 6, 8, 10. If I go by every 2, I have plenty of room to graph the 5 months I have, and then a little extra to graph more to see what's going to happen. So I'm going to go by 2. I'm going to go by ones, really. Each box is 1, but I'm going to really only mark every other one where I have the bigger marks, just to not take up so much space. So I'm going to mark my axis like this. And then when I'm looking at my my vertical axis, I know that after 5 months, I'm already at more than $11,000. So if I look at just doing by 1,000, so 2, 4, 6, 8, $10,000, $12,000, I would barely meet the top, and I won't really have much, since my graph is getting my y values are getting bigger as my x values are getting bigger. I decided to go that each box was going to be 2,000. So if I label every other one, this is going to be 4,000, 6,000, this would be 8,000, this would be 10,000, 12,000, and so on. So we start with at 0 months, which is here at the origin. We want to go $6,000, which 246 is right here. And again, at 1 month, you could do the 7,000 would be right halfway in between 6 and 8,000. It's going to be slightly above the halfway mark. At 2, you're at 81,000, so you're just a little bit above that. You can see that these are all lying in a line. I'm going to jump down to 5 months in my 11,000. So this would be 10,000. This is 11,000. This is 12,000. That would be 50. This would be 250, about a quarter of the way down. You can see that it does look like these fall in a line. I'm going to use a straight edge. I actually noticed a mistake here. If I follow these 3 points, see how that's a big outlier up there? What's my mistake? My mistake is in my scale. I went 2, 4,000. This would be 6,000, 8,000, 10,000. This should be 12,000 right here. So I skipped a mark. So I'm going to have to fix my scale. So now you can see my scale is set. So if each individual box is 2,000, like I had, 2,000, 4,000, 6,000, 8,000, 10,000, 12,000 there, 14,000, 16,000, 18,000, and 20,000. And if I, at 5 days, or I'm sorry, 5 months, is a little over 11,000, so it's going to be a little bit over halfway between the 10 and 12,000. And now you can see that that does fall along the line with the other 3 points. So we can check our remaining 2 points. After 3 months, we should be at 9,100, which would be a little bit over. So this is 8,000, this is 10,000. It would be around that halfway point between those two, and it is. At 4 months, we should be a little bit over 10,000, which is right here. So these do all fall in a line, and we can use this to get an idea. So now we can see what type of function are we talking about. Our points fell on a line, so it is a linear function. It's a linear function. We can see from the graph that the points lie in a line. You can see from the table that you're going to have a constant rate of change, 1,050 for each month. So our rate of change is a positive 1,050 over 1, or positive 1,050. And if we look in our table, we see that we have a rate here when we have 1,050 each month. Each is like per, which is a divide sign, and always going to indicate a rate. So what does the x variable stand for in the problem? You can look here. Our x variable was with the number of months. You can see it in the table, number of months. What does the y variable stand for in the problem? Well, you can see here the y-axis represents the amount paid in dollars, and you can see in the table is the dollars paid. So what is the starting point? And the starting point corresponds with the y-intercept. Again, you can look at the graph or the table or the words. So y-intercept is right here, this value of 6,000. You can see in the table when x is 0, y is 6,000, or here that we have to pay $6,000 when you purchase the car, and the purchase of the car is the start of the agreement you have with the car company, so that's the beginning. And then we need to figure out what the rate of change is. And so we have that. You can see right here, it's always the change in y over the change in x. You could see the rise over run here. As you go up 10,050, you go over 1 day. So up 10,050 over 1, up 10,050 over 1. And in the words for the problem, the monthly fee of 1,050 each month is our rate, which is the same as our slope or rate of change. And now we can use that information to write it in our linear function. And because we have a starting value, because we have a y-intercept, we're going to use the slope-intercept form. And I want to point out, we typically talk about this as y equals mx plus b, but you can add things in any order. So we could easily think of this as b plus mx. And the reason I'm writing it this way is that sometimes, because this is often the starting value, some students find it more intuitive, or it makes more sense to write that number first and then add the rate times your x variable. So you can write that in whatever way makes that more comfortable for you. The reason that works is if you think of 2 plus 3 is exactly the same as 3 plus 2, they're both equivalent to 5. So when you're adding two quantities, it doesn't matter which order in which you add those. So to write an equation that represents this situation, we have y, which is our monthly value. That was equal to the $6,000 that we had to pay up front, plus the $1,050 that we're going to pay each month. And remember, y represents each month. And you don't have to expressly put the multiplication, but as I was thinking through each step, I wrote that. It is also absolutely acceptable to write 1050x plus 6,000. It is the same. So you could kind of write that either way. Now, how much will you have paid after 10 months? Let's use the equation. So just to remind us that x is the number of months and y is the amount paid in that time. And we're wondering how much will we have paid after 10 months? So that we want to know, when x is 10, what is y? In other words, if we have 10, we're trying to figure out what is our y value. So to solve this, I have to use order of operations. So I have addition and multiplication. Multiplication comes first in order of operations. So I'm going to take my 1050 and multiply that by 10, which gives me 10,500. So that's how much I've paid each month for 10 months. I mean, the total after 10 months. And I have to add that to the $6,000 that I paid up front. I take that answer, and you can see that I have paid $16,500 at the end of 10 months. So after 10 months, you've paid $16,500. As an ordered pair, it would be 10, $16,500. Let's double check in our table and our graph. So first, if we look at 10 months, we get here, and if we follow that over, that's a little bit more than 16,000. So that's in the right ballpark. So that looks correct. If we look at our table, remember when we were putting this into our calculator, we were taking the previous answer and we were adding 1050 because that's our slope. So that was at 5 months. So this would be 6 months, 7 months, 8 months, 9 months, 10 months, and you'd see we would get here at 16,500.